So these word problems refer to what we call vertical motion problems. And vertical motion problems are a way to illustrate an object being thrown up and then falling back to the ground. So vertical motion problems talk about the height with respect to time. And if we're talking about feet per second, we're going to have negative 16t squared. It will always start off with negative 16t squared plus the initial velocity times time plus the initial height. So the initial velocity, or the initial upward velocity, is the velocity at which you throw the object. And the starting height is the height off the ground. So that's your initial height. So if I kick a ball, the initial height might be 0. But if I throw a ball, then the initial height might be 5 feet, 4 feet. It all depends on where the ball is when it leaves my hand. So a construction worker on the ground tosses an apple up to a fellow worker who's 20 feet above him. The starting height of the apple is 5 feet. Its initial upward velocity is 30 feet per second. Will the apple reach the second worker? So we're going to write the equation first. So we're going to write the vertical motion equation, and then we're going to talk about how do we use the discriminant to determine. All we need to do is determine, will it reach the worker? So the initial velocity, we're going to write this equation by filling in the initial velocity with 30 feet per second, and the initial height of the object is 5 feet. So our height off the ground with respect to time is negative 16t squared plus 30t plus 5. Now, if I want to know whether or not this quadratic has any solutions when the height is 0, it's probably going to look something like that, right? And I know that because I have a y-intercept of 5. But I want to know if it's going to be 20 feet off the ground. When it's 0 feet off the ground, I expect that the discriminant is going to come back with a positive value, giving me 2 solutions. But when I put a 20 in, how many solutions are there? If there's 2 solutions, that means there's 2 times that the object is going to reach 20 feet, once on the way up and once on the way down. If there's 1 solution, that means that my object is only going to hit 20 feet and then it's going to come down, so 20 is going to be the maximum. If there's no solutions, that means that my maximum doesn't get as high as 20. I'm falling short of being able to throw it 20 feet in the air. So we put a 20 in for the height because that's how far we want to know. Is it going to reach 20 feet? So that's the output that we're looking for. So I'm going to put my equation into standard form. So we have negative 16t squared plus 30t minus 15. And I'm going to calculate b squared minus 4ac. We're going to hope that it's either positive or 0 so that we can say that yes, it's going to reach that height. However, if we get a negative number, then we know our discriminant's negative and we're not going to get any solutions, meaning our ball won't, or the apple isn't going to get that high. So b squared would be 900, 30 times 30, and then minus 4 times negative 16 times negative 15. I'm going to take 4 times 15, which is 60, and then I'm going to take 60 times 16. So I get 960. 3 negatives multiplied together is going to be a subtraction. So 900 minus 960 is a negative 60. Your discriminant is going to be a negative value. Discriminant is less than 0. Therefore, no solution, meaning we won't reach 20 feet. Well, the apple won't reach 20 feet. So the answer is a big fat no. The apple doesn't reach the second worker. Suppose the same construction worker tosses an apple with an upward initial velocity of 32 feet per second. So now he says, okay, I'm going to throw it a little bit harder. Now will it reach the second worker? Well, let's find out. H of t equals negative 16t squared plus 32t plus 5. So nothing else has changed, just the velocity at which he initially throws the ball. So we want to know if it's going to get to be 20 feet high. So we have 20 equals negative 16t squared plus 32t plus 5. We'll put this equation into standard form. And now we're going to calculate b squared minus 4ac. So 32 times 32 times 32 is going to be 900. That's going to be 120, so that's 1024. So 1024. 32 times 32 is 1024. Minus, that's b squared minus 4ac. And I think we already calculated that. That's going to be 960. So 1024 minus 960 is a positive number. It's going to be 40 and another 24. That's 64. That's greater than 0. Therefore, yes, the apple now reaches the worker. Ta-da! Yay! Okay, so now let's see. A football is punted from a starting height of 3 feet with an initial upward velocity of 40 feet per second. Will the football ever reach a height of 30 feet? So you go ahead and try, and then come on back, and you'll watch me work it out and let you know whether or not you get the right answer. So I'm going to end up having 30 equals my negative 16t squared plus my initial upward velocity of 40 times t plus the starting height of 3. So we'll have 0 equals negative 16t squared plus 40t minus 27. B squared is going to be 1600 minus 4 times negative 16 times negative 27. It's a lot of work there. I'm going to end up having 1600 minus 4 times 27 is 108. 108 times 16 is 1728. 1728. So this is a negative number. This is not greater than 0. This is less than 0. So this is less than 0. That looks a little odd there. Less than 0. Therefore, no, football doesn't reach the height of 30. I feel like I should be checking my answer real quick because I did that math pretty quickly and I probably shouldn't have. 27 twice is 54. 54 twice is 108. So I'm confident there. 108 times 16, 48, 6. Mm-hmm. 801, yes. 8271. Mm-hmm. And 40 times 40 is definitely 16. And 3 negatives definitely make a subtraction sign. So, correct. That's the answer. Nope, the football doesn't reach 30 feet high.